Okay, so today I'll be talking on probability theory. Uh, Let us start with the probability theory today. So, with the definitions to start with. So, probability theory is a branch of mathematics that studies uncertainty and measures how likely events are to occur. Right? That is the pure definition of the probability theory. It provides tools such as sample space, random variables, and probability distributions to analyze random experiments and predict possible outcomes. So this is basically prediction of the possible outcomes. With the help of such tools, uh, the chances of occurring of any event can be ascertained. Example, like for example, a very basic example, if we talk about, is when flipping a fair coin, there are two possible outcomes, head or tails, right? Since both outcomes are equally likely, the probability of getting head is 1 by 2 and the probability of getting tail is also 1 by 2. Now, there are basically two approaches in the probability theory. One is called experimental probability and another one is called the theoretical probability. In the experimental probability, we generally do a trial or random experiment. Based on that, we try to see what are the number of cases a specific event has occurred, and then we try to calculate the probability of that particular event to occur. Right? For example, if you are doing of rolling a die 100 times, and actually you see after experiment that that 6 appearing is 23 times. So probability of occurrence of 6 on rolling the die is basically coming as a 23 by 100. That is from the classical definition of probability. Now, theoretical probability talks about purely theoretical part of the probability. Here, if I roll a die once, then what will happen? That probability of occurrence of the 6 will be 1 by 6 in this case. Okay, so the outcome is 6 actually. So that is the theoretical probability. Okay, let me move to the next slide. It talks about the pure definition of theoretical probability that deals with the assumptions to avoid unfeasible or costly repetition of the experiment. So with this, we can avoid the random trial or the experiments time, multiple times and avoid the cost involved in that. The theoretical probability of an event A is an event that can be calculated as below formula, which is we can write as P of A. Probability of A is a number of outcome favorable to event A divided by the number of all possible outcomes, right? Here we assume the outcomes of an event as equally likely. We'll come across the definition of equally likely in our subsequent slides, although now, as we learn the formula, let's put this formula in our coin tossing case as an experiment. And into a coin tossing coins, there are two outcomes. We know that head, either it will appear as head or the outcome will be tail. Hence, the probability of occurrence of a head or on tossing a coin will be P of H is equal to 1 by 2. Similarly, the probability of occurrence of a tail on tossing a coin will be P of T is also 1 by 2. Now, experimental probability, if we go, then experimental probability is found by performing a series of experiments, right? And observing their outcomes. So these random experiments are also known as the trials. Okay, so the experimental probability for event A that can be calculated or defined as P of A is basically is equal to number of times event A happened, that might be the number is P maybe, divided by total number of trials, that is N. So P by N. That is the experimental probabilities definition. Moving on to the next slide, now we learn that the formula, let's put the formula in our coin tossing experimental case. So if you toss a coin say 10 times and record it the outcome, then head appears as say for example 4 times and the tails is 6 times, then the probability of occurrence of heads on tossing a coin is P of H is basically 4 by 10, and similarly the probability of occurrence of tail on tossing a coin is P of T is 6 by 10. That is called experimental probability. Now basics of probability theory, some of the basics definitions, important definitions. First one is random experiment. And so in probability theory, any event that can be repeated multiple times and whose outcome is not hampered by its repetition is called the random experiment, right? More the number of experiment you are doing on the same thing, the outcome possibility of getting certain outcomes doesn't change, right? So that is called random experiment. Outcome will not get happen. For example, tossing a coin or rolling the die, etc., are basically the random experiment as per the definition is concerned. Sample space, next definition. So, what is sample space? The set of all possible outcomes for any random experiment is called the sample space. For example, throwing a die results in 6 outcomes, which are basically 1, 2, 3, 4, 5, and 6. Thus, its sample space is 1, comma 2, comma 3, comma 4, comma 5, comma 6 within a first bracket, right? That is how we define sample space. Moving on to the next slide, it talks about the theoretical probabilities definition. So theoretical probability deals with the assumptions to avoid unfeasible or costly repetition of the experiments, right? We do not have to repeat same experiment again and again and can avoid the costing with this definition. So the theoretical probability of an event A can be calculated as PA is equal to number of outcomes favorable to event A divided by number of all possible outcomes. Hence, here we assume the outcomes of an event as equally likely. So each outcome is equal chance to occur. Now, as we learn the formula, let's put the formula in our coin tossing case. In our coin tossing case, there are 2 outcomes, head or tail. Hence, the probability of the occurrence of the head on tossing the coin is P of H is 1 by 2. Similarly, the probability of occurrence of the tail on tossing a coin is also P of T is 1 by 2. Now, in case of experimental probability is found by performing a series of experiments and observing their outcomes. So these random experiments are also known as the trials, right? And the experimental probability of event A can be calculated as P of A as is equal to number of times the event A happens, which can be attributed as P, small p, divided by total number of trials, which can be attributed as small n. So that is P by n. Okay. Now moving on to the next slide. Now, as we learn this formula, let's put this formula into our coin tossing experiment case. And if we toss the coin 10 times and recorded the heads 4 times and tail as 6 times, then the probability of occurrence of head on tossing a coin is equal to P of H is equal to 4 by 10. And similarly, the probability of occurrence of tail is P of T is 6 by 10. Okay. Now, coming on to the some of the basics of probability theory. Important concept, random experiment. One second, I think this we have covered event. Okay, now, sorry, sample space, this is also done. So now coming into the event. Now coming into the event, the outcome of any experiment is called basically an event. Various types of events used in probability theory. One is called independent event, and then we are having dependent event, we are having mutually exclusive event, equally likely event, and such kind of events, right? So independent events are basically the events whose outcomes are not affected by the outcomes of other future or the past events of that experiment, right? Are called the independent events. For example, the output of tossing a coin in repetition is not affected by its previous outcomes. Correct? Dependent event. What is dependent event? The events whose outcomes are affected by the outcome of other events are called the dependent event. For example, picking oranges from a bag that contains 100 oranges, and we are doing that without replacement. So without replacement, if we do that, the next time we are trying to bring one more orange from here, that will affect the events. That will depend on the last time that we have drawn how many oranges from the bag and all. So that is called the dependent event, right? Outcome depends on the previous events. Mutually exclusive events is the event that cannot occur simultaneously are called the mutually exclusive event. For example, obtaining a head or tail in tossing a coin, because both head or tail cannot be obtained together, right? Together we cannot have it. Either it will have be head or it will be tail. So those are head and tail are mutually exclusive events. Then equally likely events, the events that have an equal chance or probability of happening are known as the equally likely event. Right? For example, observing any face in rolling a die, which has equal probability is 1 by 6. 1 by 6 is equal probability for occurrence of 1 to 6, any outcome. So that is equally likely event. Correct? So what is random variable? A random variable is basically can assume the values of all possible outcomes of the experiment. That experiment that you are doing is called the random variable in probability theory. Random variables in probability theory are of two types. One which are described as discrete random variable and continuous random variable. So what is discrete random variable? Variables that can take countable values such as 0, 1, 2, 3, like integers values are called a discrete random variable. Example is number of heads when flipping three coins. Okay, that will be either 1 or 0 or 1 or 2 or 3. Okay, so number of heads can be these numbers only. So these are on discrete random variable. The number of cars arriving at a parking lot, that might be 50 or 100 or 200. So that is also discrete random variable. Or the number of correct answers on a test. Correct. Then continuous random variables that can take an infinite number of values in a given range. Okay, that's called continuous random variable. Example, the height of a person. It can be, say, 5 foot 6.5 inches, 5 feet 7.3 inches, 6 feet 2 inches, like that. So it can have any values. That is why it is a continuous random variable. The time it takes for a chemical reaction to occur or the temperature of a substance. So that can be the temperature of a substance can be 33.25 degrees centigrade as well, or it can be 34.5 degrees centigrade, anything in between. It may not be always a integer, right? So this is a continuous random variable. Now there are certain probability theoretical formulas. Various formulas are used. Theoretical probability formula is basically your number of favorable outcome divided by number of total outcome. So this is a ratio. An empirical probability formula is number of times event A happened divided by the total number of trials. And there are some addition rule of probability, which is P of A union B is equal to PA plus PB minus PA intersection B. Then complementary rule probability is PA test is equal to 1 minus PA. An independent event is PA intersection B is equal to PA dot PB. And conditional probability states PA given B is equal to PA intersection B divided by P of B. And Bayes theorem is actually written as PA given B is equal to PB given A into PA divided by PB. Right? There are certain cases in the probability theory is used in statistics in different way, like this in the descriptive statistics. Probability theory helps in understanding the and interpreting data summaries and distributions, right? Summary of data, summary of all the data that you are collecting. Then in the inferential statistics, this forms the basis of the making inference about the population from the samples that you are taking, right? Including hypothesis testing and construction of confidence interval. So we'll be going through this later point in time in detail. In the regression analysis, probability distributions of errors are used to estimate the relationship between the different independent and dependent variable. And in Bayesian statistics, we use probability to represent uncertainty about parameters of interest and update this uncertainty as more data become available, right? And in practical scenario, in the applications in the real world, probability theory is widely used in our day-to-day life. It helps answers various types of questions, such as, say, for example, in the social science case, will it rain tomorrow or not? Will that be a dry day or very sunny day tomorrow, or will that be very the humidity will be very high tomorrow or not? So that is kind of probabilistic theory. What are the chances of landing on the moon? Might be from the space science perspective when you are launching, sending a rocket there. What are the chances of human evolutions? And there are many other things. Some of the important uses of probability theory are probability theory can be used in predict the performance of stocks and bonds in finance. Uh, in the casinos and gambling, probability theory is used to find the chances of winning. Then probability theory also is used on weather forecasting, and probability theory can be used also in the mitigation of the risk that you can foresee in any of the activity that you are doing day to day, or in the manufacturing plant and anywhere you can think of. And in the consumer industries, the risk of product failure is mitigated by using probability theory. By getting that probability theory value, you can take the necessary actions to mitigate the failure. So with that, I will conclude today's lecture on probability theory basics, right? Thank you very much.